Fluorine is the most chemically reactive of all the elements. As you can see, simply blowing fluorine gas onto iron powder causes a violent reaction. Clearly, fluorine is well deserving of its reputation for volatile behavior. Yet this basic characteristic gives it the enormous potential to combine with other elements. Although very chemically reactive, once fluorine reacts with other elements, it forms highly stable compounds with unique characteristics. Fluorine is most abundant in fluorspar. And fluorspar is the source of all our fluorochemicals. One example is polytetrafluoroethylene, or PTFE, a fluororesin in which all the hydrogen atoms in the polyethylene molecule have been replaced by fluorine atoms. PTFE demonstrates superb thermal and chemical resistance, as well as other excellent properties, such as low friction, non-sticking, and electrical insulating properties. These characteristics have made fluororesins an essential industrial material often used behind the scenes. It is in high demand in the electrical, electronics, machinery, and aircraft industries, as well as in aerospace and outer space development. Let's now take a look at a few experiments that demonstrate the unique characteristics of these specialty fluorochemical products. Here, fluororesin and acrylate resin are dipped in acetone, a powerful solvent. The acrylate resin has already begun to dissolve, but as you can see, the fluororesin is virtually unaffected. This time, we'll place a fluoroelastomer and natural rubber in oil heated to 250 degrees Celsius. The natural rubber begins to melt within minutes, but the fluoroelastomer remains stable. Fluorochemicals are specialty polymers that can withstand severe environments. This versatility makes them useful in various applications in the automotive and many other industries. Fluorochemicals, and especially fluoropolymers, have unique surface characteristics. For example, fluororesins have a low coefficient of friction. Here, a toy locomotive is able to climb the surface of an acrylate resin panel, yet suddenly loses traction when traveling over the fluororesin surface. Fluorochemicals are used to coat pistons, seal rings for automatic transmissions, ball valve seats, various types of bearings, and many other products because of their low coefficient of friction. One product that utilizes the low surface tension of fluorinated compounds is Unidyne. Fabrics treated with Unidyne repel not only water, but oil as well. Even sticky fruit juice can be easily wiped off a Unidyne-treated carpet. Unidyne is used to prevent stains on clothing, carpets, sofas, and many other products. Fluororesins also have many other useful properties. Their low coefficient of refraction, for example, makes fluororesins ideal as a sheathing material for optical fiber cable, ensuring superb light transmission. Unsheathed fiber, in contrast, loses a considerable amount of light. Fluororesins also exhibit good ultraviolet light transmission and weather resistance, making them popular for films for covering solar panels. Fluororesins are also used for the cables of local area networks because of their high flame retardance and minimal smoke generation. And their excellent high-frequency characteristics make them ideal for computer wiring. The evolution of fluorochemistry has entered a new phase. By combining the unique properties of fluorochemicals with other materials, we are meeting the increasingly demanding needs of the modern age. For example, our development of a new adhesive fluoropolymer and fabrication process has enabled production of an innovative automotive fuel hose. Made from a fluororesin nylon composite, it takes advantage of fluororesin's low gasoline permeation property. The result is greatly reduced fuel leakage, effectively meeting the increasingly demanding environmental protection regulations being adopted in many parts of the world. In January of 1991, we formed 2 subsidiaries in the United States, in Decatur, Alabama. Daikin America Incorporated is a wholly owned subsidiary for fluororesin manufacturing, while MDA is a joint venture with 3M. Daikin Industries is building a global network of production facilities for fluorochemical products and has established production bases not just in Japan, but also in China, the United States, and Europe. Since 1933, Daikin Industries has been taking an original approach to research on fluorocarbon gas synthesis. Backed by more than 70 years of experience in fluorochemical research, Daikin is successfully blending and combining fluorochemicals with a variety of other materials to reveal a whole spectrum of innovative possibilities. At Daikin Industries, we are committed to fulfilling the global promise of fluorochemistry in the exciting new century.